Hi, I'm Phil Cheatham out here at the Olympic Training Center in Chula Vista, California. Behind me here you can see the beach volleyball court, and just behind even further you can see Lake Otay, which is where the rowers train. Anyway, in this video segment I'm going to talk about the difference between angular speed and linear speed. So let's use the club and do a demonstration. If I take the club and hold it horizontal and let it swing back to horizontal, you can see that it swung through 180 degrees. Now, if it took, in fact, 1 second to swing through 180 degrees, then its angular speed would be 180 degrees per second. 180 degrees in 1 second, 180 degrees per second. How does that relate to linear velocity or linear speed? Well, to do that, we have to look at a specific point on the shaft. So let's take a point about 1 foot below the grip, or below the end of the club. And let's remember some of our geometry that we had when we were in high school. The circumference of a circle. Now, the circumference of a circle is 2 pi r. Pi being just a number, about 3.14. In fact, we'll round it up to about 3. So basically what that's saying is the entire circumference of a circle would be 2 times 3 times the radius. Now we're only going through half a circle, so that would be just simply pi times the radius, or 3 times the radius. Let's say that we move down a foot, so that would be 3 times 1, which would be 1. So what that means, which would be 3. So what that means is that the club swung through 180 degrees, but that point moved through 3 feet. Okay? So if it moved through 3 feet in 1 second, then that would be 3 feet per second. So the angular velocity again is 180 degrees per second, but the linear speed of that point is 3 feet per second. Now, is that any different at anywhere else along the club? Well, yes it is. Let's take a point down here at 3 feet down the club, and let's do the calculation again. Now we've got 3 times the radius, in this case being 3, so 3 times 3 is 9. So this point that's 3 feet from the swinging point would move through an arc that has 9 feet in length. In other words, if I took a piece of string and I put it around that half a circumference of the circle, it would measure 9 feet long. So now that point is traveling at a speed of 9 points per second. So again, 180 degrees per second, this point traveling at 1 foot down, traveling at 3 feet per second, this point 3 feet down, traveling at 9 feet per second. So you can see the angular speed is consistent anywhere along the shaft. However, the linear speed changes with the radius as you go further and further out along the club. That explains why a longer club can hit further, because the club head is going to be traveling faster. However, don't forget that if the club is longer, it's going to be harder to swing due to the moment of inertia of the club. That's for another discussion. Suffice it to remember that the further away from the center you go, the faster that point is moving. However, the angular velocity is always the same. Now this is important in the kinematic sequence, because in the kinematic sequence we measure angular velocity, not linear velocity. We can transpose the two or compute one from the other, but remember the kinematic sequence measures angular velocity in degrees per second.